Hello my friends and welcome back to the Futech HD channel. The process of quarrying travertine is a meticulous and multi-step procedure that starts with the identification and selection of suitable sites rich in travertine deposits. Travertine, a type of limestone formed by mineral springs, particularly hot springs, is valued for its durability and unique aesthetic properties, making it a popular material in construction and architecture. The initial stage involves geological surveys and sampling to determine the quality and extent of the travertine deposit. Once a suitable site is identified, the land is cleared and prepared for extraction. This often involves removing the overburden, the layer of soil and rock covering the travertine deposit. The extraction process begins with drilling holes into the travertine bedrock. These holes are strategically placed to create a grid pattern that will guide the subsequent cutting process. Modern technology, such as diamond wire saws and chainsaws, is commonly used to cut large blocks of travertine from the quarry face. These blocks can weigh between 6 to 15 tons each. For instance, a typical quarry might extract around 50,000 to 100,000 tons of travertine annually, depending on the size and capacity of the quarry. Once extracted, the large travertine blocks are transported to a processing facility. This transportation usually involves heavy-duty trucks capable of carrying such massive loads. At the processing facility, the blocks are inspected for quality and any imperfections are identified. At the processing facility, the large blocks are cut into slabs or tiles of various sizes using gang saws or block cutters. These machines are equipped with diamond-tipped blades that can precisely cut through the dense stone. The slabs are typically cut into thicknesses ranging from 2 centimeters to 3 centimeters, although custom sizes can be produced to meet specific requirements. The yield of usable travertine from the quarrying process is typically around 25 to 30%, with the remaining material being discarded due to imperfections or unsuitable quality. After cutting, the travertine slabs undergo various finishing processes to enhance their appearance and durability. Common finishes include polishing, honing, and brushing, each providing a different texture and aesthetic appeal. Polishing gives the stone a glossy, reflective surface, while honing results in a smooth, matte finish. Brushing creates a more rustic, textured look. Advanced techniques, such as resin filling, are also used to fill natural voids and enhance the stone's strength. Quality control is a critical step in the process. Each slab or tile is inspected for consistency in color, texture, and structural integrity. Once approved, the travertine is packaged and prepared for shipment. High-quality travertine is often exported to international markets, contributing significantly to the global natural stone industry. For instance, in 2022, Turkey, one of the largest producers of travertine, exported approximately 1.3 million tons, generating over $500 million in revenue. A block cutter for granite is engineered to handle high sheet thicknesses and incorporates structures that minimize vibrations during cutting. It features gearing mechanisms to support the advancement of extra-large discs, capable of withstanding significant loads and reversals in movement. The disc trolley is fed on V-form guides, immersed in an oil bath and enclosed in stainless steel casing, providing superior durability and cutting precision compared to wheeled models. Lateral displacement is managed with inverter-controlled precision gearing, moving on calibrated rollers in an oil bath protected by thermo-welded bellows. The cutter's mechanical and electronic components are of the highest quality. It is designed for easy maintenance, with fast access to parts requiring repair or lubrication. To maximize engine life in the corrosive granite cutting environment, the entire structure undergoes sandblasting followed by the application of a thick epoxy primer and epoxy enamel, ensuring robustness and longevity. Granite fabrication is a detailed and precise process that transforms raw granite slabs into beautiful and functional countertops, tiles, or other custom-designed pieces. The process begins with the selection of granite slabs. These slabs are chosen based on the specific requirements of the project, including color, pattern, and thickness. The inspected slabs are then subjected to high-resolution digital imaging. This process captures detailed images of the granite surface. Using the high-resolution images, a digital layout is created. This layout ensures optimal use of the material, minimizing waste and aligning the patterns to enhance the aesthetic appeal. The digital layout files are transmitted to the production floor, where the fabrication machinery will use this data to execute precise cuts and shapes. The granite slabs are loaded onto the saw line. This is where the initial cutting process begins, guided by the digital layout. High-precision saws, often CNC controlled, start cutting the slabs into the required shapes and sizes. The precision of these machines ensures clean, accurate cuts. After the sawing process, the cut pieces are carefully unloaded and inspected for accuracy. The cut pieces are then moved into a robotic warehouse. This automated system organizes and stores the pieces until they are needed for the next stage of fabrication. From the warehouse, the pieces are routed to edging machinery. These machines apply precise edge profiles to the granite pieces, enhancing their appearance and functionality. For some edging and finishing machines, the pieces need to be flipped to process both sides evenly and ensure consistent quality. After edging, the pieces are transported to operators who prepare them for further processing, such as polishing and finishing. Next, the pieces undergo edge polishing. Specialized polishing machines smooth and shine the edges to achieve a high gloss finish. Reinforcement channels are cut into the granite where necessary. These channels provide additional structural support for the finished product. Reinforcement strips are glued into the channels, adding strength and durability to the granite pieces. CNC shaping machines are used to create intricate shapes and designs as specified in the digital layout. This includes complex cuts and detailed features that require high precision. For exceptionally detailed and intricate cuts, water-jet cutting machines are employed. These machines use high-pressure water mixed with abrasive materials to precisely cut the granite. The exposed undersides of the pieces are polished to ensure a smooth, uniform finish that complements the top surface. Skilled craftsmen perform hand finishing to refine details and ensure the highest quality finish. This step addresses any minor imperfections and enhances the overall aesthetic. If the granite pieces include sink cutouts, anchor holes are drilled to accommodate sink installation. The finished pieces undergo a final inspection to ensure they meet quality standards. The Hirado K25 rock splitter is a cutting-edge tool designed for efficient and safe demolition in various environments. It excels in breaking both concrete and rock with minimal noise, vibration, and dust, making it ideal for sensitive sites such as hospitals, subways, and construction projects with stringent regulations. Operating with a maximum splitting force of 6.5 meganewtons, the K25 delivers substantial power while maintaining a lightweight and mobile design. This powerful force enables it to handle tough materials with ease. Despite its robust performance, the rock splitter is renowned for its silent operation, producing noise levels of less than 65 dBA, which is significantly lower than traditional demolition equipment. The K25's versatility is further enhanced by its compatibility with Hirado's hydraulic pumps, whether air or electric, and can also be used in conjunction with Hirado's booster for low-pressure pumps. This adaptability allows the rock splitter to be effectively employed in a range of settings, from quarries to more confined spaces. In addition to its operational efficiency, the K25 rock splitter is designed to be dust-free and vibration-free, ensuring a cleaner and safer working environment. Its ability to perform silent demolition without creating excessive debris or vibrations makes it a valuable tool for projects where noise and disturbance must be minimized. Ceramic manufacturing is a complex process that involves several critical stages to transform raw materials into high-quality ceramic tiles. Gayafores, with over a century of experience, has perfected this process using state-of-the-art technology to ensure superior quality and aesthetic appeal. The process comprises the following steps: raw materials preparation, spray drying and pressing, glazing and decoration, firing, and sorting and packaging. Raw materials. The journey of ceramic tiles begins with the selection and preparation of raw materials. The primary components include various clays, feldspar, sand, carbonate, and kaolin. These materials are meticulously sourced from mines and quarries to ensure consistency and quality. Once collected, the raw materials undergo a mechanical milling process to disperse the particles and reduce their size, ensuring uniformity. Gayafores has its own glazing warehouse silos and unloading bay for the treated clay, underscoring their commitment to quality control from the very start. Spray drying and pressing. After milling, the raw materials are transformed into atomized dust through a process called spray drying. This step removes water rapidly, resulting in spherical and hollow granules essential for pressing. The granules are then fed into a silo and subsequently into the press, where they are compacted under high pressure. This pressing process breaks the granules, allowing the particles to re-adhere and form a cohesive tile with sufficient mechanical strength. The damp tiles are then dried in a horizontal dryer, achieving a residual humidity of around 0.5%, which makes them sturdy enough for the subsequent glazing and decoration processes without becoming too fragile. Glazing and decoration. The dried tiles proceed to the glazing line, where they undergo multiple layers of slip and glaze application. An interface material called englobe is applied between the clay base and the glaze to ensure proper adhesion. Gayafores utilizes advanced digital ink injection technology for decoration, allowing for high resolution, up to 400 dpi, and contactless ink application. This method enables the creation of intricate designs and effects, such as stone, wood, rustic, and marble patterns, with remarkable precision. Additionally, the technology allows for the application of various materials and effects, enhancing the tile's technical properties like impermeability, chemical resistance, and non-slip surfaces, as well as their aesthetic qualities. Firing. Firing is a crucial step in the ceramic manufacturing process, solidifying the tiles and enhancing their durability. The tiles are fired in single-layer roller kilns using very fast firing cycles of about 45 to 60 minutes. These kilns, which are gas-fired, feature a relatively low yet wide chamber and can accommodate a large number of tiles simultaneously. The maximum temperature during firing ranges between 1,100 and 1,200 degrees Celsius. The process is highly optimized for heat recovery to reduce fuel consumption, with hot gases preheating the tiles in the initial firing stages. This efficient system allows for the production of a large quantity of material in a short time. Sorting and packaging. Once fired, the tiles undergo a series of quality control procedures. The first step involves a visual check using artificial vision equipment operated by an inspector, who ensures the design and color tone of each tile are consistent and free from visible defects. The tiles are then sorted based on their size and flatness, adhering to specific standards to maintain uniformity. After sorting, the tiles are boxed and stored until they are ready for distribution. This section is going to show you a simple way to make concrete model bricks, perfect for your next project. This method is efficient and budget-friendly, making it ideal for DIY enthusiasts. First, gather your materials: cement, sand, gravel, and water. Mix 1 part cement, 2 parts sand, and 3 parts gravel in a wheelbarrow or mixer. Gradually add water until you achieve a thick, workable consistency. Next, prepare your molds by coating them with oil to prevent sticking. Pour the concrete mix into the molds, filling them evenly. Use a trowel to smooth the surface and remove any air bubbles. Let the concrete cure for at least 24 hours before removing the bricks from the molds. For best results, allow them to fully harden over a few days. The manufacture of hydraulic mosaic is a specialized and intricate process that has been perfected over generations. Antonio Benito Gigante's hydraulic mosaic, with more than 50 years of experience in the concrete pavement sector, epitomizes the dedication and expertise required in this craft. Located in Tamaloso, Ciudad Real, this family-run business is now in its third generation, continuing to produce high-quality hydraulic mosaics using traditional artisanal methods. Hydraulic mosaic, known for its decorative appeal, is produced in various sizes such as 20 by 20, 25 by 25, and 30 by 30 centimeters. These tiles are versatile and can be used for both floors and walls. What sets hydraulic mosaic apart is their commitment to personalized, bespoke designs. Each tile is crafted to meet the specific tastes and requirements of clients, ensuring a unique and customized product. The manufacturing process begins with the preparation of a high-quality cement mixture. This mixture includes high-resistance cement, marble powder, and siliceous aggregates, which provide the tiles with their durability and strength. Natural pigments are then added to this mixture to achieve the desired colors and patterns. These pigments are chosen for their quality and longevity, ensuring that the tiles maintain their vibrant appearance over time. The next step involves the artisanal creation of each tile. This is a meticulous process where the mixture is poured into molds, often made of metal, which shape the tile and its intricate patterns. These molds can be customized to create a wide variety of designs, from simple geometric patterns to more complex, artistic motifs. Once the mixture is in the mold, it is pressed hydraulically to remove excess water and compact the materials, enhancing the tile's strength. After pressing, the tiles are carefully removed from the molds and left to cure. This curing process is crucial as it allows the tiles to harden and reach their full strength. Once cured, the tiles are meticulously inspected for quality, ensuring that each one meets the high standards set by hydraulic mosaic. The result is a beautiful, durable, and unique hydraulic mosaic that embodies the tradition and craftsmanship of this family-run business. The process begins with the preparation of raw materials. The primary raw material is clay, which is fed into a grinder and pulverized into a fine clay powder. This clay powder is then combined with other ingredients, such as quartz, feldspar, and water, in a mixer. The mixture is refined over a period of about 15 hours to create a homogeneous clay slurry. Once the clay slurry is ready, it is fed into molding tubes and cast into long clay logs. These logs are then cut into specific portions, known as clay discs. Each disc is placed into a single-use mold and formed into the shape of a mug. Mug handles are created in a similar fashion to the mug bodies. Once the handles have dried and been released from their molds, they are dipped in a mixture of clay and water called slip. This slip acts as a glue to attach the handles to the mugs securely. Technicians carefully remove any excess clay or rough edges from the mugs, rinsing off any dust or debris to ensure a smooth finish. The mugs are then glazed to achieve their color and finish. Some mugs are dipped into a single-colored glaze, while others may have more intricate designs, such as painted rims or different colored interiors and exteriors. This step is done by hand to ensure consistent quality and a high standard of craftsmanship. After glazing, the mugs are left to dry completely for at least 12 hours. The dried mugs are placed on a conveyor belt that carries them through an oven, where they are fired at a standard temperature of around 2,200 degrees Fahrenheit. This high heat causes the mugs to harden permanently, giving them their durable and finished form. Once out of the oven, the mugs are inspected for any defects and subjected to quality control checks. Finally, the finished mugs are wrapped in plastic, boxed up, and shipped to customers around the world. Some mugs may remain blank, while others might have logos or text printed on them for branding purposes. The next time you enjoy a hot beverage in your favorite ceramic mug, take a moment to appreciate the intricate process and craftsmanship that goes into producing these everyday items. The production of handcrafted ceramic tiles is an intricate process that blends traditional craftsmanship with artistic flair. It begins with the careful selection of high-quality clay, which is then shaped into tiles using molds. Once shaped, the tiles are dried to remove moisture and then fired in a kiln at high temperatures to achieve the desired hardness. After the initial firing, the tiles are glazed with a variety of colors and finishes. Artisans often hand-paint intricate designs onto the tiles, adding unique patterns and motifs. The glazed tiles undergo a second firing to set the colors and finish, ensuring durability and vibrancy. Each tile is a unique piece of art, reflecting the skill and creativity of the artisan, and adding a touch of elegance to any space. The PLC-controlled multi-saw granite block cutting machine significantly enhances efficiency by saving manpower and time. It operates with a 200 kilowatts engine and is equipped with 64 saws, each 1,300 millimeters in length, allowing it to cut 2 to 3 slabs, each 480 millimeters wide. This machine, first manufactured in Turkey, can produce up to 300 square meters of granite slabs daily, which is 2.5 times more than the older model. The process begins with the granite block being cut by the machine. The cut block is then transported by a wagon to the automatic vacuum bottom cutting machine, where a horizontal bottom cut is performed. Following this, the stone is sized using the single band conveyor. This entire production line operates automatically without human intervention, utilizing a ring system for continuous operation. The saw machine for marble and natural stone cutting, specifically designed for accurately cutting marble blocks into slabs, operates with a combination of high-tech components and precision engineering. Here's an in-depth look at how it works. The central element of this machine is the blade rack, which is fixed and guided by a hydrostatic linear guide system. This system ensures that the blade rack remains in a steady, linear form, countering forces from various directions during the cutting process. The hydrostatic linear bearings reduce friction, allowing the machine to operate at high speeds without vibrations, which is crucial for achieving smooth, clean cutting surfaces on the marble slabs. The main shaft, made from forged steel and tested for cracks and porosity, is a robust component of the machine. It undergoes hardness and material analysis after heat treatment to ensure durability. The shaft's movement is transferred to the blade rack through a system of connection rods and a flywheel. This assembly is engineered to balance dynamic forces, ensuring the longevity and stability of the machine. The flywheel and the main shaft are connected via a belt and pulley system, which is independently tensioned to maintain power efficiency and reduce unnecessary power consumption. This setup minimizes excessive amperage draw and enhances the machine's operational efficiency. The columns, forming the main structure of the machine, are manufactured from corrosion-resistant materials using advanced welding technology. They are designed to withstand impacts and vibrations, providing a stable framework for the cutting operations. The elevator system, which moves the marble blocks up and down, is guided by V-prismatic guides on two columns and flat guides on the others. This dual guide system ensures precise and smooth vertical movement, facilitated by low-friction materials. The screw nut mechanism, driven by gearboxes, allows the elevator to handle heavy loads with ease. Stainless steel covers protect the screws from contaminants, and lubrication windows simplify maintenance. A central automatic lubrication system ensures continuous oil flow to the hydrostatic linear guides, elevator slides, screws, and nuts. This system minimizes wear and tear, reducing maintenance needs and extending the machine's lifespan. The machine's design allows it to cut multiple small blocks simultaneously, enhancing productivity. The high-speed cutting capability, combined with the long cutting stroke and maximum block elevation speed, ensures that the marble slabs have uniform thickness and a slick surface from start to finish. Safety features include double safety systems for the connection rod shafts and secure locking mechanisms for the block trolley during cutting. The machine's components are designed for easy maintenance, with replaceable guides and bearings. The closed-loop lubrication system for the roller bearings and the easy-to-access lubrication points for the screw nut mechanism further enhance the machine's operational reliability.